We're given mass percents, and we're asked to find the empirical molecular formulas. Let's assume that we have a 100-gram sample of this unknown substance. If we have 100 grams of this compound, then the chlorine component will be 71.65 grams. And the carbon component will be 24.27 grams. And the hydrogen component will be 4.07 grams. We can do this because percent composition is an intensive property. It's the same percentages no matter how much mass you have of the compound. And the reason we want grams is because we want to be able to get moles. So let's use the molar mass found on the periodic table to convert these grams into moles. Chlorine has a molar mass of 35.45 grams per mole. So set up your conversion factor so the grams cancel out and we're left with moles. Now carbon has a molar mass of 12.01 grams per mole. And hydrogen has a molar mass of 1.008 grams per mole. These types of problems you don't need to be super precise, but it doesn't hurt. All right. So for the chlorine, we got 2.02 moles. For carbon, we also get 2.02 moles if we had a 100-gram sample of this compound. And for the hydrogen, we have 4.04 moles. So at this point, you might be able to see that the formula can reduce to Cl, well, I'll just write it the way it is right now, Cl2, C2, H4, which reduces to Cl, C, H2. And so that's your empirical formula. To take the smallest result and see how many times it goes into each of the results. So that's how we get the one there. That's how we get the one for the carbon. And that's how you get the 2 for the subscript for hydrogen. So you would get the same answer. It's just a little faster if you can see it conceptually. All right, so we have the empirical formula, and we're given the molar mass. Yeah, we have to give you the molar mass in order for you to get the molecular formula. So we want to see how many times the empirical formula mass goes into the molar mass. All right, so chlorine has a mass of 35.5. Let's just round a little bit here. Carbon has a mass of 12, and the 2 hydrogens has a mass of 2. That's 49.5 is the empirical formula mass. So now we want to see how many times that empirical formula mass goes into the molar mass, which is around 99. So that's going to be 2 times. It's always going to go in a whole number of times because the empirical formula is the lowest whole number ratio, and the molecular formula is always a multiple of that. So the molecular formula is Cl2, C2, H4.